Chapter 7. We are right back into algebra. Everything up till now that we've been, we took a break from algebra. We were doing more geometry. Now we're back to algebra, all of our letters and everything. So we're going to be filling out page 259, 261. We're looking at simplifying algebraic expressions. Now we've done this. We have done this in the past. We're just going to, so I'm going to remind you, and then we're actually moving on to a little bit more complicated expressions. Now we're dealing with like terms. Now remember, like terms are things that have the same variable, that same letter next to them. And now we're also going to define that as raised to the same exponent. So here, if we're combining like terms, 1x plus 2x, these are like terms because they both have x. I can combine those, and I could write that as 3x. If I had x squared, 1x squared plus 3x squared, I can combine those because they're both x squared, so that would be 4x squared. I can do the same thing with subtraction by taking something like 5y to the third, and I can subtract from that 2y to the third because they're both y to the third. And so 5y cubed minus 2y cubed, this is going to be 3y cubed. But I cannot add or subtract x and x squared because these are different terms. So 1x squared cannot be added to 1x cannot be added to 1x squared. Why? Why can't I? Because x is not the same as x squared. They are not like terms. So in an example, they have Alex and Derek are buying apples. And Alex buys 2.5 pounds, and Derek buys 3.5 pounds. So they say, okay, what's the expression for what they buy all together? So you can write this: Alex, the amount that he spends on apples is 2.5 times the price of the apples. Derek, how much he spends on there is 3.5 times the price of the apples. So I can combine these two terms because they're both p, and when I do that, I get 2.5 plus 3.5 in parentheses times p. This is just the reverse of the distributive property. And when I add my 2.5 plus 3.5, that gives me 6p. So the cost of the apples that both Alex and Derek paid is going to be 6 times whatever the price of those apples are. And like I just said, we used the distributive property because 2.5p plus 3.5p, I can group those numbers together and put p outside. And this is just the opposite of what we did before. We've done the distributive property before, but we started over here. And we said, all right, so if I have p, I can multiply p times each term inside these parentheses to get this guy. So the distributive property can go either direction. Now, they want you to figure out how much was actually spent. So P is how much the apples cost. And they tell you, all right, assume that P, the cost of the apples, is 90 cents a pound. So if that is true, then you just need to replace everywhere that you use P. Okay? So our equation here for the cost at the beginning was 2.5p plus 3.5p. And when we simplified it, it became 6p. And they want you to check if you replace p, 2.5 times p, and we'll write 0.9 instead of p, plus 3.5 times p, is that going to be the same as writing 6 times p? Are they the same? They want you to verify that. All right, so another example. So we have example 2. In example 2, I don't know why they used M for nuts. They just did. But they are choosing for the cost of nuts to write the variable M, and the cost of the cheese they're calling C. Now for a class party, both Devin and Kim are going to bring both nuts and cheese for the party. So Devin buys 2.5 pounds of nuts and 1 3/4 pounds of cheese. Kim buys 1.5 pounds of cheese and 1 1/4 pounds of nuts. So all together, you would write everything that Devin bought or brought is the 2.5 pounds of nuts and the 1 3/4 pounds of cheese, and then you would write everything plus everything that Kim brings, which is 1.5 pounds of cheese and 1 1/4 pounds of nuts. Now, this big long expression can be simplified by combining like terms. So every term that has an M is a like term, and every term that has a C is a like term. So this 2 1/2 M we can combine with this 1 1/4 M. And I did that right here. I used my distributive property and I said 2 1/2 plus 1 1/4 in the parentheses and M. So that's these two terms together. Then I did the same thing with my C terms. I took my 1 3/4 and my 1 1/2, and I pulled those two numbers out and put C on the outside, and I have my 1 3/4 plus 1 1/2 C. So I combine those like terms. So this whole expression here can be rewritten just like this expression. Now we used the associative property. We just we associated my M terms together. We used the commutative property. We just switched the order because this M was at the end and I wanted it next to this property. And we used the distributive property because we combined those like terms together. So this 2 1/2 plus 1 1/4, that became combined together and M was written on the outside. And the 1 3/4 and the 1 1/2 were written together with the C on the outside. So those are our three properties that we used. Now once I do that, then I just need to add them together. And this 2 1/2 plus 1 1/4, that becomes 15/4 M. I want you to double check that. We've done that with our addition of our fractions. And then our 1 3/4 plus 1 1/2 C, that adds together to be 13/4 C. Now this expression right here, this represents how much is spent on both the nuts and the cheese. So this is how much they spent on nuts. This is how much they spent on cheese. If I give you the price of nuts and the price of cheese, you can figure out how much was spent total. Now, question 2A asks why bother, and you don't get to say you don't. And it's not because Mrs. Graham's making you. What they're asking is, why is it good to take this expression here and go through the work to rewrite it like this expression here? Why is that a benefit? What does that help you do? I mean, how is that easier? Okay. Then they also want you to think about how is this two variable equation, meaning I've got two different letters. Okay. How do you work with this two variable equation? How is that the same as working with the one variable equation, which is what we did back in the earlier chapters? We might have worked with this, but we would just not have had a C term. We would just have had an M term. So how is it the same, even though we added a second term? And then your 2C, they want you to try this. So I want you to go ahead and I want you to look at that expression and I want you to see what you can do about it. Combining those like terms. The homework for this section is page 263, 264. As always, you are welcome to continue working ahead.